Hi everybody, I've had a lot of questions out of 5.3 and how to use SALT with a binomial distribution. So I'm going to take a look at that, here. And I have SALT pulled up. It says USA Today reports that 25% of prison parolees are repeat offenders. That is not a success to be a repeat offender. So not success in this problem would be 25%. The ones that don't become repeat offenders is the other portion of the 25%. And I think we all already know that 25% and 75% are the two parts that will make up the whole here to make our binomial. So in the work that we do, it typically will say P is the probability of success and Q is the probability of failure. So I'm going to say a repeat offender would be a failure. So Q is 25% or 0.25. So that means that not being a repeat offender will be 75%. So 75% is going to be our success. Alice is a social worker. She has been given a group of 4 parolees, and it wants to know, find the probability that you have 0 repeat offenders, 1, 2, 3, and 4 repeat offenders. Right, and it ranges from 0 to 4 because n equals 4 in this problem. As they told us, Alice has been given a group of 4 parolees. So anytime once you find n, you need to find out the probability from 0 to n. So I'm going to come over and choose binomial distribution because they're either repeat offenders or not. Those are opposites of one another. That's what makes this a binomial. There are 4 trials, so because there are 4, it tells us that she has a group of 4 parolees. And the probability of success, again, I said failure is 0.25, so probability of success is 0.75. Remember, probability is always a decimal number between and including 0 and 1. So we just change our percents to decimals. Okay, what I'm going to do here is come over here and click equal because I want to know what is the probability that x is equal to 0. And it asks me to round to 3 decimal places. So the probability of there being 0 repeat offenders is 0.004. Okay, then the probability, and if you'll look at the graph over here, it put in orange just the 0. Probability of 1 is, and we can just hover over them. We don't have to change that every time. 0.047 rounded. 0.047. The probability of having 2 repeat offenders. I think I can hover over it again for some. There we go. Well, it's not doing it for me. So, well, either way, we can go put a 2 here, and it'll give us the answer here. 0.211. Let's try the hovering again. Okay, or if I come here and I hover, I think it's just because I have everything pulled up. So the probability that when x equals 3 is 0.422. When I round that to 3 decimal places right here, and the probability that 4 do not become repeat offenders is 0.316. Okay, so again, probability of success is 75%, and then the probability of failure is the 25%. Not probability, those are the percentages, and the matching probabilities then are 0.75 and 0.25. It says make a histogram. Well, I already used SALT to do that, and if we come and we take a look at this histogram, it increases, goes up for the number 3, and down a little bit at the end, so that matches up with this first one. It certainly doesn't match up with any of the other ones. Okay. What is the expected number of parolees in Alice's group which will not be repeat offenders? Okay, the ones that will not be repeat offenders, remember, were was the 75%. So it's the 75% of the 4 that Alice is looking at is the expected number in her group that will not be repeat offenders. The standard deviation is found by finding the square root of, oops, the square root of n, which is 4 in our problem, times the probability of success, which we've been using as the 0.75, times the probability of failure, which they usually use Q to represent in these problems, which is 0.25. So enter there, and I'm rounding that to 2 decimal places. So the standard deviation of the Perles is 0.87. All right, and then the last one says, what is the smallest group that Alice can cancel to be 98% sure? So we want to know what's the smallest n we can have, because we've been working with 4. But it wants to know what's the smallest group so that 98%, she's 98% sure that 3 or more parolees will not become repeat offenders. So 3 or more will not become repeat offenders. I'm going to go back to the SALT here, and we leave the 4, we leave the 0.75, and we want to know what is the smallest group that she can cancel so that 98% 3 or more. 3 or more is right-tailed, and if you don't know that, think about it. You want this to say more than or equal to 3. So for 3 or more, the probability when she has 4 parolees, the probability of having 3 or more not being repeat offenders is 73.8%. Okay, we want that to be at least 98%. So the group that only had 4 in it, that will not give us the 98% that we're looking for. So I'm going to change the number of people in our group to 5. If we change it to 5, the number for the probability of being greater than or equal to 3 not repeat offenders is 89.6%. So I'm getting closer. Let's try 6. If I have 6 parolees that Alice is counseling, then that is 96.24%. So it looks like we're almost there. Let's see if 7 works. If she has 7 parolees and the probability of success is 0.75, then the number of parolees that she could have that would be greater than or equal to 3 of them, which is at 3 or more parolees that would not be repeat offenders, is 98.7%. So she would have to have at least 7 parolees in order to be able to have 3 or more of them that are not repeat offenders. So I hope that helps you. Sorry this video got a little bit long, but that's what it took. So enjoy using SALT. It's very helpful.